Hi everyone! Welcome to my math tutorial. Today, we're going to learn about fractional inequalities. Don't worry, it sounds so hard, but I'll make it super easy and fun. So, ready your notes and let's get started.
So now let's proceed to our first example. Our first example is x plus 5 over x minus 2 is greater than 0. Now, it is already one fraction, so we are good. Step 2 is we need to find the critical points. Let's find where the numerator and denominator become 0. So, let's write numerator. So, our numerator is x plus 5 equals 0. And then it will become x equals negative 5. Now, our denominator, x minus 2 is equals to 0. And then it will become x equals 2. Now, this is now our critical points. Now, for the step 3, we need to draw the number line. So first, we have to draw a line, and then we mark the center 0, and then we mark negative 5, and then positive 2 on the number line. So now we will use open circles because our sign is greater than, so it is not equality included.
But wait, how do we know if the numbers in our interval should be included or excluded? It's simple. If the sign is greater than or less than, that means the number is excluded. We use an open circle on the graph. But if the sign is greater than or equal to or less than or equal to, that means the number is included. We use a closed or shaded circle on the graph. So remember, open circle excluded, closed circle included.
So we have to use open circles for the both of them. So let's mark our intervals now. So negative 5 is with negative infinity, and then let's connect negative 5 and then positive 2, and then positive 2 and then the positive infinity. Now let's write the intervals. First interval is negative infinity and then negative 5. Second interval is this one, negative 5 and then positive 2. Third and last interval is positive 2 and then positive infinity. So it is, let's write positive 2 and then positive infinity. Now this 3 is now our intervals. Now for step 4, let's test each intervals. First interval is negative infinity and then negative 5.
How do we know what number to test? Just choose any numbers that is between the points in your interval. It doesn't need to be perfect. Just pick a number that's simple and easy to use.
For this interval, we will try x equals negative 6. We test by substituting a number from each interval into whole fraction, which is our equation. We will substitute using this equation. So, we will substitute negative 6 to this. negative 6 plus 5 over negative 6 minus 2. So negative 6 plus 5 is equals to negative 1. Negative 6 minus 2 is equals to negative 8. We will divide that. It is now equals to 1 over 8. 1 over 8 is greater than 0. It is true, because 1/8 is greater than 0. So the first interval becomes true. Now for our second interval is negative 5 and positive 2. So let's write it here. Negative 5 and positive 2. So let's do the same process, but we need to find a test point first. So we will try x equals 0. So we will substitute the 0 to our fraction here, this one. So it is 0 plus 5 over 0 negative 2. Solve this. So it is negative 2.5. So negative 2.5 is greater than 0. It is not greater than 0. So it is false. So this becomes false. Now let's try the last interval, which is the positive 2 and positive infinity. Same process, but we will try here is x plus 3. 3 plus 5 over 2 minus 3 minus 2. Now let's solve that. So 3 plus 5 is equals to 8 over 3 minus 2 is equals to 1. So this becomes 8. So 8 is greater than 0. It is greater than 0. So this becomes true. Now we want to take the greater than 0. So we will take the positive intervals. This is positive and this is positive. So the answer is
let us now proceed to our second example. Our second example is 3x over x plus 1 is less than or equal to 1. Our first step is make it one fraction. We subtract 1 from both sides, so it will become 3x over x plus 1 minus 1 is less than or equal to 0. Then we simplify the top part, which is the numerator. 3x minus x plus 1 close parenthesis over x plus 1. So that becomes 2x minus 1 over this, just get x plus 1. X plus 1. Now our inequality is x minus 1 over x plus 1 less than or equal to 0. Now for the step 2, let's find the critical points. These are the x values where the numerators or denominators become 0. Let's start with the numerator. We have 2x minus 1 equals 0. First step is we need to add 1 to both sides. So it is 2x equals 1. Then divide both sides by 2. 2. So this is now our numerator. Next, let's look at the denominator. Our denominator is x plus 1. Now, we set x plus 1 equals 0. Now for the step 3, plot the number lines. Let's make a line first. -1 and then 1/2. -1 open circle, while we will mark 1/2 to close circle.
To avoid any confusion, let's write included and excluded to our numerator and denominator. So next, let's write the intervals. This interval is -infinity and -1. So that is open and close parenthesis. The next interval is -1 and +1/2. -1 starts with open parenthesis, while the 1/2 is bracket because it is included. The last one is 1/2 and infinity. So start with the bracket and 1/2 and infinity, positive infinity, and then close with the close parenthesis. Now this tree is now our intervals. Now for the step 4, test each interval. We'll test one number from each interval by substitution. Now let x equals to -2. Now let's substitute. 2 times -2 is equals to -4, and then get the -1 over -2 plus 1 is equals to -1. Next, -4 minus 1 is equals to -5. Bring down the -1, and then that gives us +5. Less than or equal to 0. 5 is greater than 0, so it is false. So now let's proceed to the second interval, which is the -1 and +1/2. For the second interval, I'll use x equals 0. X equals 0. Same process, we just substitute it. 2 times 0 is 0, so we just need to get the negative 1 over 0 plus 1 is equals to 1. So that gives us negative 1 is less than or equal to 0. It is true. Now let's proceed to our last interval. For the third interval, I'll use x equals 1. Same process, substitute. So 2 times 1 minus 1 is equals to 1 over 1 plus 1 is equals to 2. So that gives us 1/2 is less than or equals to 0. 1/2 is greater than 0, so it is false. Now, let's look at our test results. The first interval gave a positive answer. The second interval gave a negative answer. And the third interval gave a positive answer. Since our inequality is less than or equal to 0, we only take the interval where the expression is negative, and that is the second interval. So, the answer is...
And that's how we solve rational inequalities. Always remember the steps. Make it one fraction, find the critical points, test each interval, and then write the final solution on the number line.